If you looked inside your cell phone, you would find a microphone just like this, and they're small. I mean really small, but that doesn't mean that they're hard to assemble. Like they say in the Hitchhiker's Guide, just don't panic, and really you don't want to drop this thing. If you do, you'll never find it. So take your time, set it down. No need to worry if it's perfectly aligned, but for this next part, you're going to want your nerdy glasses on because these capacitors are tiny. Just add a couple to the board. They got to be straight-ish. But once you're happy with it, just throw it on the hot plate and turn it on and see what happens. You're gonna see it sizzle, and when it basically hits the right temperature, you're gonna know when. And when. So, cool. Now we got this thing working, just gonna go and solder on a couple headers. Plug in some wires to my super advanced, basically voltmeter. Record this using an ESP32. Can you hear me now? Good. I made plenty of small mistakes when assembling this, and it still turned out fine. I mean, it worked, right? Don't worry about getting it perfect, just try to get it done when you're starting out. I've got a cold solder joint right here on the ground pin because I didn't wait long enough for my soldering iron to heat up. I used too much solder paste on this and not enough paste here. I even dropped the board during the first take and had to go and stick 2 capacitors back on, but the funny thing is, it still worked. I've heard engineers who design these components say, they often work despite what you do, not because of what you do. I'm not trying to say that these details don't matter. Eventually they do. But for now, probably not as much as you think. Until you're working with high power systems, radio frequency RF, or super precise sensors, most things will just work fine. Perfection is an illusion. You're never gonna even get there, so don't even try. Just get it good enough and move on. This is that voltmeter I was talking about earlier, the one that's so precise and so fast that I was able to read a basic microphone directly without any amplification, and it's only a few dollars per board. When you get started, you're going to probably need to order parts for every new PCB you make, but eventually you're going to acquire quite a few and you can just start making new projects based on the parts that you already have. I had all these parts laying around. Most of these components are things I just use on every board, so I just go and keep them in this kind of generic common container. So first thing you're going to need to do is clean your soldering iron, because if you're going to try this with a soldering iron, you're going to need all the help you can get. You're going to want to flux your parts, adding a little bit of this liquid flux to the pads. You might want to pre-tin them. I'm not the biggest fan of pre-tinning them all. As you'll see, I think it just adds too much solder, because now when you're trying to get on that first side, well, it's kind of raised up, and try to get that other side and it just doesn't really work. So I'm not the biggest fan of this method. I think it can work, other people do like it. However, this is my preferred approach. Put a nice fresh ball of solder on one side and try to push, well, try not to do this. Try to grab a hold of it. Hold it until you let go of the solder and it cools down. Flip around the board, add solder to the other side, and remember, you don't add solder quite to the tip. You add it to the connection, and you'll see it flow right in like that. But the problem with the soldering iron is that there's all this solder. It's ugly, it's not the best connection. You didn't quite get underneath the capacitor to the PCB that well, even if you try to reheat it. So I'm going to show you a better way, at least my opinion. It's using solder paste. Because when you use solder paste, you're able to get underneath that component, have that component in great connection with the PCB. But the problem is, if you don't use that much paste, well, first off, it doesn't want to really stick down that component. And second, well, that solder's not really grabbing onto that component. So what I like to do instead is I like to add a lot more paste than I normally would. You're trying to get really good contact on the bottom, going up the sides. You're just not going to get that if you add just a little bit of solder paste. I'm going to drop this capacitor in, and you're going to see it really sits in well. You then push it down with the tweezers, and when you hit each side, see how that solder just ramps up? This is about as good as you're going to get hand assembling one at a time with a soldering iron. But I'm going to try to do it the right way according to using a soldering iron. Add solder to one side, firmly grasp the capacitor or resistor, and put it in exactly where you want it when the solder is molten. Lift out the iron, and you should have your capacitor, whatever, staying perfectly in place. Then just go around to the other side, and remember, add solder to more of the connection, not quite to the soldering iron tip. When you finish using your soldering iron, remember that Hot stuff corrodes quickly, so see how hot that is? If it's just left out in the air, it's going to be corroding quickly. It means that your soldering iron tip isn't going to conduct heat as well in the future. So what I like to do is leave it coated completely in solder. You'll see other people do this. They got various ways. I just keep on adding it. And if you add too much, no one cares. Just add a little bit more to cover it again and let it cool down. And if you want some help, take that exhaust fan that you should be using whenever you're using a soldering iron, turn it around and have it blow on the tip instead of sucking air away from you. So my favorite tool isn't my soldering iron, it's my heat gun by far. All about my hot plate, and I think you'll see why. It can be really hard to describe how tiny a lot of these components are. So if you try to go and solder a resistor, what happens? You have to kind of touch the resistor, which moves the resistor. So that's what I love about solder paste in the heat gun, is that ideally you can add some solder paste, take your really tiny component, just go and stick it on, hit it with the heat gun, and then, well, turns out even with the heat gun you can blow it around. So what I like to do is, instead of trying to mess with it and blowing it in the right place, just give a little nudge back. And then if you get the heat gun just angled right from the above format, it ends up just not really moving it that much. It just melts it in place and you get a fantastic joint. But what I like even better is just going and just mixing up a little bit of this solder paste and just going to town with it. All you're really trying to do is just kind of get a dab that just about covers each pad. You don't have to overthink this, just a little dab of solder, a little dab on the pad. You can use anything to apply solder paste. A toothpick, I'm using a through-hole resistor wire. Really, anything will do. Just work your way around the board. And when you get to this big chip, yeah, that's the thing. You can do that. Watch, it works fine. Everything looks good. There's some that has a little bit too much on it. Just trying to use a little bit of liquid surface tension to pull off a tiny bit. Just moving it around, trying to make sure everything has a decent amount of solder on it. And now all you gotta do is just start plopping on parts. Trust me, this is the easiest way to flip this thing around. Just kind of throw it up in the air, move it around. Eventually, it'll land the way you want it. So now we just need to start adding a bunch of resistors. Just try to go and do a little magic dab and get exactly 6 resistors out. Plop them on one by one. And remember how hard that was with soldering? Remember how time consuming that was to do each? Now just bam, bam, bam. Add a couple capacitors. We're gonna add a big capacitor, a medium capacitor, and a small capacitor because I want to use this for a different purpose than what I built the board for initially. And all you gotta do is just go around and just take your time. With these big chips, I'd recommend doing this little drop on the board. What that does is that aligns the pins perfectly with the plane of the board. So that way this next move just works so much better. Just go move it slightly. And then once you feel it just about right, and drop it, and it just hopefully is good. And if it's not good, well, you'll see it for sure. Just go and move it around, and at some angle, some perspective, you'll see it's off or correct. So I'm just gonna try to give it a little nudge, and most time nudges end up screwing up stuff more than helping. So try to get 1 or 2 nudges to get it into place, and eventually you'll be happy with it. So just go and toss on the rest of the components. You can see that we're just going around adding some various parts. That's a diode. We're gonna add some capacitors. And if this board was a little tighter together, this last piece might be hard to get in, but it's a pretty open board, and well, it's looking good at this point, except for that. Just nudge that back into place and maybe add a little solder paste, pass it on a hot plate, Bob's your uncle. All PCBs are basically assembled in the same way. It doesn't matter what type they are, such as if they're a big old power board like this, one of my favorites, has a huge fuse, has MOSFETs rated in the hundreds of amps, and you still assemble it the same way you would assemble something like an ESP32. In the next video, we're going to start with like this development board for an ESP32, make our own version of it that's basically an exact clone of it, and then we're going to shrink down our clone because we know it's working in some smaller form factor that we can put into some 3D printed case with some custom cover or something like that on it. And it just doesn't matter what you're making, it's all the same process. So you might as well have a desk that's at the perfect height for it. I can tell you that I assembled for years on an old card table, and having something just the perfect height means, well, I don't quite need these anymore. When you can have it just the right height surface, I think that's worth it. One of my favorite things is that it's also a mobile desk. I can easily go in, lock it down and have it not move at all. But the thing is, if I want to move it to another room, I just unlock it, move it over, and I'm starting to bring my desk to me wherever I am. So if you want to support the channel, support your lower back, support better posture, go and please check out the link in the description and check out FlexiSpot. They make great desks. So I mean, it's good for up to 300 pounds, whatever you're doing. It doesn't matter if you're editing, playing video games, sending long emails. I think this is the right desk for you. You're probably getting the idea that you can come back from just about any mistake, and you're right. When making a PCB, it's pretty simple. I mean, there's a couple things that can go wrong, but mostly just get out your toothpick or resistor and solder paste and fix any mistakes you got. Then throw it on the hot plate and see what happens. Even these attempts where I'm basically sabotaging myself to show you mistakes and how to fix them, it's still working out well. You'll see things move around, some wiggle a little more than I'm used to, but the heat moves from the inside to the outside of the board, just kind of cooking stuff as it goes. Well, this fault was all mine. I tried taking off the PCB a little too quickly while it was still molten and knocked off some things. So let's go and get out the good tweezers, not the silver ones, but the ones that are anti-static, kind of the ESD. I'm gonna definitely need some solder wick to remove some solder like paper towels are to water. And then I'm gonna need these nerd goggles because I'm gonna need all the help I can get.
You kind of have to be a cool kid to wear one of these.
Here's the problem. I knocked a couple capacitors sideways and now they're not really where they should be, and I don't have enough solder on the board to actually go and get them soldered back on. You can see I'm trying and nothing's really happening. So instead of kind of just messing around with this, what really needs to happen is I need to use my favorite tool, the heat gun, and just kind of get it hot enough to remove each individual capacitor. And if it's not coming up yet, just let it get hotter. Crank up the heat if you want, but eventually it'll come off. And at this point, we can go and use that solder wick with a little bit of flux on it and a soldering iron to just kind of soak up that hot solder into that copper braid. You can see I actually missed some of that solder there. I didn't get all of it off, but we're gonna try anyways. We're gonna use our soldering iron, get it nice and clean, add a little dab of solder on one side of it, just like we did before, and then grab the capacitor, and we're gonna be careful this time. Get it exactly where we want it, put on the soldering iron to melt that solder on one side, and hopefully it'll just stay put right where we want it. And it actually kind of pulled away at the last minute. So all you got to do is just go and hit it with the soldering iron again, move it where you want it, move the iron away, and it should be fine this time. Add a little dab of solder on the other side and you're good. But for now, we're going to try to add solder paste on the other capacitor, and you'll see there's too much solder there. And too much solder paste now. So try to get it off somehow, use surface tension. This isn't working though, so I'm gonna upgrade and use my favorite, the toothpick. Just do a little roll like this, roll on something else, and you can actually get a good amount of solder off, but sometimes you can just kind of wiggle it around and kind of make a little dashed line in the center, and that's good enough to separate the two sides. And now I get to use my favorite tool again, and I'm just careful to hold down that capacitor, and whenever I needed to adjust the tweezer, I just make sure to move away the hot air gun for just a split second, adjust the tweezers, pin it down again, and just do that until it's fully melted. And now we have ourselves a fixed PCB. It looks pretty decent, it's just missing some headers, but we'll get to that next. Flux is gonna be your best friend here, because headers, they're kind of hard. That's a lot to solder. That's a big thing to solder compared to the rest. So this flux just makes sure that all those joints just go a little bit smoother than they would otherwise. I like also using this liquid flux because you'll just need all the help you can get. So just kind of scrub it on, plug in a header. I'm just gonna tack weld it on so that way I can go back and use my thumb while hitting it with a little more heat just to get that in the final place I want it. And once I'm happy with it, Go back and try to get a good solder joint on it. But the thing is, this isn't hot enough. These headers, they require a lot of heat. So crank it up as high as you need. And when it flows, well, it's still not flowing because it's a ground pin. The ground pins are always more difficult because they're connected to a lot of copper in the board. But once it flows, you start going and you just keep on going. Keep that temperature up. Don't worry if it moves quickly. That's fine if a solder joint happens quickly. You just don't want it taking 10-20 seconds. So get it warm, maybe fix your previous joints that are a little cold, and then start rocking on. Just get your next header going, get everything lined up, and before you know it, you're just going to be going to the motions. Now for the last part, because this is a ultra sensitive device. It measures so precisely. You're gonna be measuring more static than actual good information. So what you're gonna wanna do is have ideally as good a connections as you can with whatever you're sensing. That's why these screw terminals are great. Instead of just having a janky jumper wire, you can go and screw the wire right into them, making sure you have a really good connection. But you'll see a lot of the modules you buy from Arduino label things, well, they don't quite have straight terminals, and well, this is why. It's so easy, if you're not being careful, to get really crooked terminals. So we're just gonna remove these. We're gonna use a solder pump, and you also use a soldering iron. What you're trying to do is get it hot, and then use this little tube type thing to suck up the solder. But you gotta like get it hot, really quickly move it and suck it, but it doesn't work well. So I use one of these. It's both of these combined. It's basically a soldering iron and a solder sucker at the same time. But you gotta wait till they get hot. That's hot enough. So now all you gotta do is go and take the single pins that you want and go and put this around it and press this button and bam, easy as that. Go on to the next one, press the button, you're all good. Go to the next, rinse and repeat. This is the easiest thing that you will do to remove pins, I promise. But the thing is, if you wiggle them a little too much when trying to remove them, you're probably gonna end up doing what I did here. This is called a lifted trace. Basically, you pull too hard, kind of pulled up the piece of tape type thing. And what can you do to get it back down? Well, super glue, and you basically have to kind of like scrape the top of that green stuff off it. But really, this board is kind of trash for what its intended purpose is. It's supposed to be a ultra precise device, and every little mistake we've made so far has taken away from that precision. Every joint that's not perfect, everything that's not quite straight, it's not a big amount it takes away, but it's a subtle amount. This board is a bit of the extreme, where all the little bits of inaccuracy are enough to really matter. When you get into radio frequency or wireless stuff, all that build quality matters too. But for almost anything else you do, it's going to be more forgiving. If we look at this under a microscope, you're going to see basically everything is correct. Everything is connected where it should be. Everything has a decent solder joint. You don't need a lot of solder for most things. You just need enough for a good connection. And well, we got that. Yeah, the board's dirty. You normally clean it when you're done. You use a little bit of like pure alcohol and a toothbrush and kind of scrub away the flux and those little solder balls that you see around. You can put it into an ultrasonic cleaner if you want. Gets all that yellow stuff out, gets that dog hair out, whatever you want. You can basically just go and clean up your board easily. But let's say you have one last bad problem. Let's say you have some bridged wires. What do? Well, you should know. You can just clean these wires, these pins, with a little bit of solder wick. But the thing is, you gotta cut off just a little bit of it, add this flux to it, hit it with the soldering iron, and you see it gets it just as easily as paper towels to water. And just kind of take your time, go around, and just get any extra solder you need off. But let's say you want to add more. How do you do that? Well, like sponge in reverse. So you're gonna take your wick, you're gonna purposefully add solder to it, and then bring that solder soaked sponge over, hit it with a soldering iron, and it will just go and deposit a little bit of solder on each of those pins that it's connected to or touching. So that's it. We did all the things that you could do to screw up a board, and we still got through a workable example in the end. Is it as good as the original? No, but pretty dang close. I remember being so intimidated trying to assemble my first board. I thought it was just something that I couldn't do. Like I lacked something to be able to move some small thing around. But it turns out, even with the shaky hand, like I have frostbite on my hands. If I can do it, what's holding you back? I just decided I'm just gonna try it, and it worked. I mean, it wasn't the best assembled first board, but it worked. And then I assembled another one, and that was better, and another one, and it was even better. So I just hope that you have the confidence to go out there and try to assemble a board yourself. But if you don't know how to make a PCB, I got a video about that. If you want to know how to find chips that are worth making to a PCB, I got a video about that. If you want to figure out how to get started in electronics, I got a video about that. But the thing is, I just want you to have the confidence to go out and build things. So whatever it is, I hope you go out there, make something awesome. You got this.